Hi there, this is session 36 of programming from the very basics using Python. In the last two sessions, I focused on file IO. I introduced you to the concept of open function and what it does, right? I told you about opening files, which are primarily text files for both reading and writing. I told you how to read from the file or how to write to a file. I talked about read mode, append mode, write mode, and also towards the end, towards the last session, I told you the R plus and W plus. I just gave an insight about it. And I told you the best practices for managing text files. In this session, I will focus on binary files first, and I'll also give you some more interesting things that you should know about working with files. So let's get started. So if you're dealing with binary files, what are binary files? Files that are not textual in nature, obviously. So you can't just really open it up in a text editor and read them. Program source code are text files. This notebook could also be in a textual format, which you can open in an editor. It'll have a JSON data, or even your normal text files, right? We type in your notepad and save it as .txt and so on. Configuration files, XML files, HTML. So all of these are text documents ultimately. But then if you create a file in a tool, like maybe if you're a Windows user, if you try creating it in MS Word, Microsoft Word, or if you use even Excel, or if you're creating a binary program, if you have any binary programs which are executable binaries, or even images. So all of these are binary file formats, which means that they store data in some kind of a raw format based on the file type, and they are meant to be managed by some special tools or programs. When it comes to binary executables, the operating system will know how to read them, how to find out all the program segments and load them in memory. But if you're looking at image files, you need an image viewer or any kind of tool that can let you process images, right? Image files. Or if you're looking at Word documents, you need some kind of a word processor tool to understand what those files contain and make it presentable to us, right? But then if at all I try opening such files using Python, let's say I'm going to use open function here. So here I'm going to open one binary file, which is nothing but a program executable binary. I'm just selecting /bin/ls here. This might not be reproducible on machines like Windows, right? So in Windows, you don't have this tool perhaps, and you don't have this path. So you can try with any .exe file if you know the path to it. And yes, be careful. Don't open it for write mode. In case you have permissions, the file will get overwritten. You won't, okay? So you have any other binary files like images and so on, which you don't care about, you can try opening them using this technique. Just make sure you provide the right path. I'm not going to pass second parameter, so I'm just going to open it for reading. Now when I try to say as in file, opening a file will not cause a problem. The moment you try to read from them in Python, it will raise an exception, and a very strange one at that. You can see that right here. So we just do a line is equal to in file dot read line. I'm trying to read a line. It doesn't make sense to read a line from a binary file. I'm going to attempt doing that. I'm not going to do anything else, but when I run this, just see what happens. If you get this error, Unicode decode error, you can see this Unicode decode error. UTF-8 codec can decode bytes so and so value at position 24, blah blah blah. It tells you all these details. What this means is that the open succeeded opening the file, but it created a text IO wrapper. And when you do a read or read line, it tried to read the underlying data and transform it to Unicode compliant string. And that transformation failed. And that's where you get this error, which means that file is having data which is not Unicode compliant, so you cannot present it in a textual format. So you cannot really create a string object out of it, right? So that's the reason why you get this error. So the right way to read all these binary files would be to actually open them in binary mode. In case I want to read this ls program in binary format, I could actually use /bin/ls and also pass mode is equal to, let me leave this cell there so you can see exactly what happens when you try to deal with the binary file. I'm going to make a copy of the cell. So in the next cell, which is there, all I do is type mode is equal to R. And I had to also put a B here. That extra character B indicates read in binary mode. So that's another character that you need to use. You can use RB for reading a binary file, WB in case you want to create a file where you want to store raw bytes into it. no Unicode translation, anything as such. So raw binary data, if you want to write, you can open in a mode called WB. You can also use AB if it makes sense. You can also append to a binary file, but I'm using RB for reading. So when I do this time calling read line might not really make much sense because in a binary file, they're not line separated. They are like raw binary data. The right way you want to read it is you want to read the entire contents by using infile.read. You get the entire contents of the file in here. Assuming the files are small, like binary executables are generally maybe they spell to megabytes or maybe about 100 megabytes. Assuming that you have that amount of memory on your computer, you should be able to read it. This program should be much smaller, right? Maybe a megabyte perhaps. So if at all I try to print contents now, this prints up as a byte string. You can see it shows up as a B quoted string. Oh yeah, the entire contents are printed, so you can see it's like a long scroll to the right. Okay, so yeah, try to print the entire contents. But you want to find out what's there in this, you can actually do a, I can just do a print len of B. Will tell you how many bytes are being read. Oh, not B, I think it's contents, right? My mistake. Len of contents, it tells you that it read about this many bytes from the file. In our bytes object, the len indicates number of bytes that it represents, right? Every item is 1 byte value. So I talked about bytes object already. In case you missed it, just go back to the session where I talk about working with strings. There's a series of session. Walk through them. I think I covered in depth about bytes object and also another variant called byte array. All these are built-in types, right? If you're trying to read raw binary data, the right object to represent them is bytes object. And bytes, I told you, forms a kind of relationship with tuple. That means you can treat it more like a tuple of single byte values. So if at all I want to find out what's there as the first byte, or if I want to iterate over, let's say, maybe the first 256 bytes of the file, maybe I can do that. I can just say for C in contents of, how do you read the first 256 bytes from this bytes object? The bytes object is quite long. It's got about, it's about 142280, right? So it's like a 142,000 bytes, whatever it is, like 1.4 MB roughly, right? So if you want to read that, it's not 1.4 MB, sorry, 142,000 bytes. So 142 KB. So if you want to read from there, maybe the first 256 bytes, or maybe the first 16 bytes, let's assume. Mostly the ELF headers. If you look at ELF binaries, I think they'll go up to 52 bytes. It'll be about 40 to 52 bytes, around that number, right? So if you want to read that ELF header, let's say, I can use colon, let's say I'll try colon 48. Let's try to read 48 bytes. This is how we get a slice. I can print the characters. Each of these are byte values. The first byte is 127, followed by 69, followed by 76, followed by 70. These are the values being stored. If you try to iterate over a bytes object, you get each item as a number representing what value is stored in 1 byte format, right? You can see that right here. So if you know how the ELF header format is, you can actually try to find out, okay, this byte, this is the signature, this is the architecture it's meant for, and all the other details. You can get to know about the section header details, program header details, and all that. Right? So all that can be read. If you're assuming that you know the format, it works with the same for even images. Most of these binary files would have some kind of headers which will contain some metadata about what that file actually contains. If you look at image headers, they contain all these details about the image format and the image dimension, the resolution of the image, and whether it's RGB or does it use the other kinds of color coding conventions. And it may also tell you about the compression level if it's a JPEG image. And it may also contain some extraneous headers like the metadata information that you store in the images, like the shutter speed and other details, right? There are a lot of details that you can actually read. So each of them have their own formats that you can go through. There are a lot of websites that actually document these details. So this is how most of these binary file processors manage to figure out each byte what they represent, and they work accordingly. There is a module called struct module, which is in the Python standard library, which makes it easy to try to represent that stream of bytes into different formats, read them accordingly into some kind of a template, and maybe represent it as a Python tuple. You can do that. Yeah, struct.unpack and pack mechanisms to let you achieve that. I will cover that much later, perhaps. But for now, you should know that when you open a binary file, you need to open it using RB, or if you want to write to it, WB. The B is important. And what you get is not a text IO wrapper. In fact, I'll show you the file object indeed. I forgot to show you this. I'll create another cell for this. I'll just create just one more cell. This time, I'm going to print in file itself, type of in file. And I don't care about reading the file and all that. Because you open the file for reading in binary mode, what you will get is an instance of a buffered reader. This is the class that represents raw binary data stream that is meant to be read, right? So you can see that it says raw, it says io.buffered reader, name is equal to /binary and it says there's an instance of buffered reader. If you try to open a file in write binary mode, you will get a buffered writer. That's the instance of the class that you get, right? So from this, you can find out whether it's meant to be read or written to using binary format, which means when you do a read on this, what you expect from it will be a bytes object. So some of you might ask me, can I read text files in binary mode? Yes, you can. So it all depends. So let's say that I just say with open off test file.txt. It's a normal text file. It's in file. This time I do a print test in file. It shows it's an instance of text IO wrapper, right? So that's what you get when you open this file. So if you don't pass second argument, it'll open for reading as a text file. So in text mode. So if you try to reopen this file and pass a parameter, let's say mode is equal to RB instead. You can see it's a buffered reader. So you can see the difference. So the mode B makes all the difference, and it works amongst all platforms, be it Windows, Mac OS, Linux. This feature is quite uniform, right? This mode as such. If you open a file for write mode, let's say with open of maybe new file.txt. I'm just calling it txt, but when I say mode is equal to write as out file, and if I try to print what out file is, as usual, because I did not specify whether it's a binary or text, the default, it'll open in text mode. So what you get is a text IO wrapper again, just that the mode is for write, so you can write to it. It's a writable stream. They can invoke write or write lines if you prefer. But if you try to open the same file with mode is equal to WB, you got a B there. Now you can try to print this. You can see you get a instance of a buffered writer. Out file is now a buffered writer. So if it's a buffered writer, what you write here is that if you just try out file dot write of, if you just type, let's say hello, if you just say this is a test string, this will fail. The write method on buffered writer objects, right? Write method on buffered writer objects, they expect a bytes object to be passed, maybe a bytes or a byte array, but they don't work with a string. They don't work with a string. So you need to pass a parameter, which is a bytes object here. You can do it by using B quotes, or you can also construct a bytes object from a string. And I told you how to do that. You can simply use bytes of string, comma, encoding. I think also you can use string.encode. If you already have a string object and you want to write it on a file that's open for write mode in binary mode, then you can use the string object dot encode of the encoding. I also told you about cadet if you want to detect the encoding and work accordingly. Right? All this can be used. So this is what you should note about working with binary files. As usual, when you work with binary file for reading, when you invoke read with no arguments, the entire file contents are read. There are often times when you want to work with very large binary files. Let's say a big movie stream, which could be a very big file, right? We can run to gigabytes, several gigabytes. Of course, today's computers have enough memory where you can read an entire movie stream into RAM and manage them if you have several gigabytes of RAM. But in sometimes you might not be able to afford that amount of memory to be allocated, or maybe you don't have that amount of memory and you want to read them chunk by chunk. So maybe you want to read one frame at a time or so on, assuming what the frame size is. You determine that and you read them. So it's called chunk reading. So how do you do chunk reading? This is how you do. Let us say I open this file again for binary mode. Let's take /bin/ls. Rather than ls, I will show you a text file, but I'm going to open in binary mode. We get a bytes object, right? I'll use testfile.txt. I'll open in. Let's say type mode is equal to rb as in file this time. And now, if I do if I just say data is equal to in file dot read with no arguments. Remember, though the file contains textual data, purely textual data, this particular file, because I chose to open in binary mode, it returns a buffer reader object rather than text IO wrapper when you try to open the file. And when you invoke read on it, it would actually return a bytes object and not a string. So there's something that you should know about. So we just try to do print data. What you get is a bytes object. You can see it. It's chosen B codes, right? It reads in raw format. So in case you want to read files into bytes, raw bytes, and process them, you know what mode to use? Use RB when you're opening the file. It doesn't matter whether the file contains textual data, binary data, it'll just work fine. But in the file, if you know it's only made up of binary data, you should open with mode is equal to RB and you'll get bytes object. You cannot obviously open it in text mode, right? So things that you should be aware of. So when I actually read this file, the entire file contains a rate, which has this entire long bytes object that you see here. But maybe I don't want to read it like this. I want to read, let's say, chunk by chunk. As for a simpler example, for simple analogy here, I'll make the chunk size as small as 10 bytes at a time. I want to read 10 bytes. But in real world, you will decide the chunk size to be a couple of kilobytes, maybe 4 kilobyte or 8 kilobyte or some number like that. And you'll want to process one chunk at a time, maybe, right? So you can adjust that. So this is not built into Python. We need to build our code for it. But how does it work? Here's a principle. Read without any arguments reads the rest of the file from wherever the file cursor is. The file cursor is in the beginning when you open the file, so it reads the rest till the end of file. But if I want to tell Python to read just about 10 bytes or 20 bytes or whatever number, you can pass that number as a parameter here. So I'll just copy the cell one more time. Hang on a minute. I sometimes click on this and it shrinks it down. Copy the cell. This time, I'm just going to show I said data is equal to infile.read of 10. It only reads the first 10 bytes. Now, because I'm outside the with clause, the file is closed. But I can call this multiple times in a loop. I can say maybe print data here and repeat this statement. It read the first 10 bytes, then read the next 10 bytes. The size might look a little varying when it's getting printed because new line is printed with the /n. That could be a reason. But if you look at the length of it, there'll be 10 bytes in here. There'll also be 10 bytes in this particular bytes object. That's a guarantee, right? Though the string representation of it can look a little off here. So if you look at the size of it, if you look at the length of it, there'll all be 10 bytes. Oh, sorry, lane of 10. So I just type lane of data here. You can see that, right? Now, in case I want to do this in a loop, right? I could build a nice utility for that. One of the ways I can do that is this particular function. Here you can put this in my own utilities module and use it as my own custom utility. But for now, I'm going to show you that function. What I'll do is I'll type def. I'll say read binary file, or maybe you can pass the file name and chunk size. I'll say the default chunk size, just for our purpose, I'll put it as 10, but you can adjust it to the default chunk size to whatever number you want. But the user can call it with any other chunk size. That's a default argument that can be overridden, right? So here, what I'll do is, as a with open of file name, read binary mode. So I can pass it just as RB. I always prefer using mode is equal to that actually enhances readability. So I recommend that. Just putting a magic RB there. Some people who come from C background, or if you know what you're doing, you might figure out the second argument is the mode. But to make it more intuitive, it's always a good idea to put mode is equal to RB. Makes it more explicit, right? So I can just say as in file. Remember, I'm using in file. You can give any name you want. I can call it as, pin file or whatever. It doesn't matter, right? Or I can just use, don't use in. In is a keyword. You can't use in. In many languages, you can use in as a name of a variable, but unfortunately, you cannot do that. Maybe I can use in as that indicate in stream, right? Maybe input stream, called in stream. And then I can use a while loop here. And this is the kind of while loop I would use in the latest editions of Python, from Python 3.9, because I'm going to be using the Walrus assignment. If you're using very old versions of Python, you might need to write more lines. You need a while true loop there, right? So here I'm just going to type chunk colon equal to, and I can just type in stream dot read of chunk size. You might wonder, what am I doing here? In stream.read of chunk size. Chunk size, if it's 10, that means the in stream, that is the input file that's open, read 10 bytes from it. And that is returned as that chunk. If you reach the end of file, you no longer have any more data. In many other languages, you get some special EOF error or some kind of exception could be thrown and so on. But in Python, whether you open a file in text mode or binary mode, if you keep reading iteratively, once you reach the end, if you try attempting to read, you will get an empty string or an empty bytes. That's it. No EOF error, no special EOF marker, no special value will be given to you. You will get empty string or empty bytes. When the chunk is an empty string or empty bytes, in this case it will be empty bytes, it will evaluate to false in the Boolean context, and that's what I'm using here. Some of you might put it more explicit. While len of chunk is greater than 0. No, you don't have to. This is more convenient, more Pythonic. And I would say here, yield the chunk. That's it. Oh, this is a generator. And that's what I want to show you. That makes it a nice, interesting utility. That's it. 3-line function. Yeah. One more thing I see is that it looks like a staircase, right? Def, width, while, yield. Some people don't like it to look like a staircase, but in this case, I don't think there's any other way to optimize it. This is how we do it, right? So indentation, you can see 3 levels of indentation here, more than 3 levels. You can see 1, 2. I think the first one is like 1. There are 4 levels of indentation here. So normally, if you have flow control constructs like if condition, inside that you have nested if condition, inside that you have nested if condition, that is a bad idea because flow control confuses. When you go to multiple levels of nesting, you reduce it and flatten it. But here, it's not about flow control. The with clause is a context manager technically, right? It's not changing the flow or anything else. It's just a context manager. In that, the only flow control concept have is while, and the body of while is just a yield. So yeah. Anyways, so to use this, I can try simply for block in read binary file of any binary file. Let's say slash bin slash ls. I'll show it ls a little later, but for now I'll show it to you with, okay, I'll use ls, no problem. You can change it to any file here, okay, the path. So whichever file you do. Even text files will work. It'll just show up as bytes object. But I'm trying to open ls program and I can specify what the chunk size is. But if I don't specify that, the default would be taken in, which is 10. But I want to override the default and say I want to read chunk size of 5 or chunk size of 20, any number. You can pass the second parameter. I guess you know about the default arguments. So I covered it in the session where I talked about functions, right? And now if I try to print block, the entire ls commands output is printed in, so you can see processing one block, another block of 10 bytes. I can read 10 bytes from the file using this simple idiom. This is like a reusable function that you can use in your own module, and it will work for all kinds of binary files, right? All kinds of binary files. So this is a simple use case scenario. when you're dealing with very large binary files. And this can be used for working with binary files with run to several gigabytes. So you're reading 10 bytes in such case will take a long time, but then you can read maybe, you want to read 1 MB at a time, or maybe about few kilobytes at a time as per your needs. And this works quite well for that. So this is something that you should know with working with binary files, about working with binary files. So I told you how you can open a file with the extra mode switch called B to indicate Python that I'm interested in reading in raw binary mode or writing in raw binary mode. And so it works, right? So that's about it. The next thing I should not talk about is some interesting patterns that you should be aware of. These are like questions I could ask. Let us say I have a file, a text file rather, which has many lines, which may have about, maybe I have about, let's say, hundreds of lines. Maybe it's a log. I want to read the first 10 lines of a file. 10 lines. For keeping things simple, okay, I'll create a file of 30 lines, let's assume. How do you create a file of 30 lines? You might ask me. I can use a simple logic here. I can say with open of, let's say, new file.txt, open for write mode, text file. I'll use mode is equal to as usual. As out here. And then I can do a loop here. I can say for I comma, or I can say I in range of 1 comma 31. I want to count from 1 to 30, so the range looks a little weird. Start from 1 up to 31. Otherwise, I'd use like I plus 1 inside your code. Okay, so I'm just using this way. If I can just use print directly. I told you that you can use print to write to a file, but remember, the file must be open in text mode, not in binary mode. If you want to use print function onto a file that's open for writing. So I'll say print pretty straightforward, isn't it? So I can just use this. I can say file is equal to out. That's it. So this will create a 30-line file. We'll just print this is line 1, this is line 2, this is line 3, this is line 4. That's about it. Very simple file. In fact, I will show you that file in my command line here. Hope I'm in the right folder now. We will cat new file.txt. This is what it contains. The 30 lines starting from line 1. See, the line 1 to line 30. Just a demonstration, but it can be any text file. Okay, any text file. From a file that's got about 30 lines, like you see here, I want to read the first 5 lines. This, you do so by using the head command on Unix. Use head -5 and file name. But how do you do this in Python? What's a Python equivalent of reading the first few lines of a given file? Think. Maybe you can pause the video, try it out, and check for the answer when I show it here. Right? So what I want to do is I want to read the first few lines of a very large text file. Maybe the first 10 lines. Some of you might think of doing a lot of logical thinking. I've seen many people do this. I would say with open of new file.txt, mode is equal to, the mode is not mentioned here. I can just open in read mode, right? As in file. And then instead of calling it in file, yeah, it's fine. Doesn't matter. The variable, I'm just choosing some silly names here because these files, I'm not trying to intuitively define what they are, whether they're logs or what they are. It's a normal file I'm reading for input. They call it in file. But in reality, you have to use some more meaningful names in your production code. So I'll just use here. Most people, what they do is that they would say maybe for I in range of 10 or maybe 5, like this. And then they will try to access every line like this. You can just say maybe, print in file dot read line. This works. But I would say that this is not really Pythonic. I wonder what's wrong with this. Oh, I'm using Python code here, right? What's wrong with this? What if the file had less than 5 lines? What if the file had less than 5 lines? Maybe I will take another file which has only 3 lines. Is there any file like that? Okay, I'll create a file here, or I'll do one thing. It's easy for me. I'll say head minus 3, new file.txt, first 3 lines. Store it to end.txt. I'm running a Unix command, okay? Don't worry about this. So just get a file with 3 lines in your machine to test it, okay? So I'm doing the Unix way. Now I'll copy this and try it with this file called end.txt, which has only 3 lines. You see a lot of blanks that comes up here. This loop tries to run 5 times, even though the number of lines in the file are maybe less than 5. If it's more than 5, it works perfectly fine. Less than 5, you have 2 more iterations unnecessarily. Imagine this, if I try to run this as a, if I also print a message, I want to read each line and also do some processing and print a message. Let's say I'm reading. This way. You see that? 2 extra reading came up there with blanks. Suppose you have, let's say, about a several thousand line file, maybe a file that's going to 10,000 line or 20,000 lines. I want to read the first 100 lines. 100 lines. Yeah, I'll read the first 100 lines. But there's another file which has only about 5 lines. But this loop will run 100 iterations anyways. Reading, a lot of blanks. This is not the right thing to do, right? What do you do now? The other option that people think of is anyway keep reading from the file, and you have to put one more condition that if that read it in a line, if the line is empty, then break out of the loop. You read every line and check if the line is empty, break out of the loop. Line will be empty. See, some of you might think even a blank line will show up as empty. No, blank line will contain a /n in it. That's how you get blank lines, by adding a new line. So if you see a blank line in files in the midst, right, you have some paragraph, you have blank lines and paragraph. The blank lines will show up as a line with /n inside them. The length will be not 0. It's not an empty string. But when you get an empty string, you can be 100% sure that you reach the end of file. So people might check for that condition and break out of the loop. That's one way to do it. Right? If at all I want to handle this, one way to handle it is I could read this line separately. Line is equal to infile.readLine. And then I can check if not line. That means if line is empty, if it evaluates to false in Boolean context, break out of the loop. Otherwise, print this line. Print the line. This sort of works. And that's why I told you this code is not Pythonic, because you have to add all this logic. Now, what would be the Pythonic approach? Anybody figured out? Well, this is how you do it. The trick is not by directly using this for loop with range. I want 5 lines. But what I'm going to do now is I can say I, line in zip of how many lines I want. Let's say 5 lines this time, followed by the file object. And then I can just say print reading line. The number of lines in this file is less than 5, stops. You know the zip object takes 2 iterables, range of 5 in 5. If any one of the iterables run out of iteration, it stops. So which means that in this case, infile runs out of iterations quicker. After 3 iterations, it runs out. Zip stops, raise stop iteration right there. But if all the infile is large, that means you have a large file. Let's say I'll use new file.txt anyways, which has got 30 lines. Now range will run out of iterations first, so it'll stop iteration. If any one of them stop iteration, zip will stop iteration when it's iterating over it. That's one of the practical reasons why the built-in zip is a short zip. It stops at the shortest iterable past its argument, right? So there's a practical use case for it. So this is also Pythonic, and you can see this is how we can implement head-like functionality in Python just in 3 lines of code. Yeah, some of you come from shell background will say, "Oh, I can do it in one line, shell command, head minus 3. But you use a command called head, which does all the work for you. But here, you're doing it in a programming language in a program. So you're creating a program called head using Python, right? That's how it is. I'm going to leave it as an exercise for you to try and find out how to read the last 5 lines of a given file. Try it out. And let me know if you got the answer. Post it on comments. So what I want to do is not the first 5 lines. The file can be arbitrarily large. It can be 100 lines or 1,000 lines. But I want to read the last 5 lines of a given file. Last 5 lines of a given file. And that too in a memory efficient manner like this. Because I'm not reading the entire file here. So the moment the range runs out, maybe the in file could have about 1,000,000 lines. But when range of 5, once you hit that range of 5, right? I mean, so once you start counting 0, 1, 2, 3, 4, the range object raises a stop iteration. When you call next, it's not going to read any more from that file. So it's processing one line at a time. So it is memory efficient. Because you're doing iteratively, you're reading line by line from a file. You're not reading the entire contents. But I want you to do the same thing and try implementing a logic to find out reading the last 5 lines of the file. Try explore. Let me know, right? And yes, if you go and put this on a chat GPT or things like that, I think it'll give you an answer immediately, and that's like cheating. I mean, you'll not do the exploration. I always tell you that. I want you to self-explore, try to find a way out, and see what's a problem you face. And maybe you can post it on comments. Maybe you come out with a complex logic. It's perfectly fine. Post it on comments. And I'll do reply with an optimal solution for that, right? So in Python. Anyways, of course, hint, you can't do it with standard libraries. And I mean, you cannot do it with built-ins, I would say. You need to take a help of something in the standard library, okay? That's something you should know. So these are things you can perform when it comes to working with files. Now, there are a lot of practical use cases for working with text files, which I'll show you some of them, some patterns. And one of them would be, let's say that I have some kind of a CSV file, a comma separated value file, which is one of the file formats where you can store your spreadsheets, most spreadsheets, Excel inclusive. When you're saving your Excel document, you have an option where you can say export to or save to and save it in CSV format, which will store it as comma separated values line by line. So I'm going to just manually type a file like that. I will show you some interesting things you can do with it. Let's say I have a simple file called, inventory.csv. I'll create a text file here. And maybe this inventory contains 3 columns. One of them is like, maybe I have a small computer store, a PC store, and I'm selling a lot of computer components, let's assume. Maybe I have a motherboard. I'm making it super simple. So in reality, you want to put the motherboard model and the SKU and all the stuff. Just keeping it simple, okay? Motherboard. And the second, after the comma, I want to say how many motherboards I have. Maybe I have stocked about, let's say, 20 motherboards. It's a small store. And price for each motherboard, which I have with me, let's say, I'm going to put in rupees, in Indian rupees. So I'm just going to use some number, like say, it's going to cost about 7,500. All of them are the same type of the motherboards, let's say. And I also have something like maybe RAM. And let's assume I have, let's say, about 30 RAM modules. And each of these RAM modules is going to cost about, let's say, 5600, the number. And maybe I have CPUs. And maybe I have a lot of them. Maybe I have, like, say, 10. 10 is a whole lot, I would say. But it's a very small store. And let's say the price of this, let's assume it's a fairly pricey CPU. I'm going to put 15,000 per CPU. So basically what I see here is the product, the quantity, and the price per piece, price per unit, right? That's what I'm trying to represent in this CSV format. You can take any CSV file of your choice, but I'm just using a simple example here, right? And maybe I can also add something else. Maybe I can use power supply units, we call it PSU, and let's say I have about 5 of them, and each of them costing about 1,500 rupees in India. So let's assume that. So, and some cabinets, let's assume. Let's throw in some cabinets in here. Maybe how about 7 of them, and each cabinet is costing about 3,000. A very small, minute inventory, but a small store, let's assume, right? and I save this file as a CSV file here. Remember, the extensions don't matter. Extensions are for only our understanding. So in a Python code, you can just read any file, give the full path to it, it'll work, right? It's just a text file or a binary file to Python. It's an inventory.csv. It's a very small file in it. Oh, Rainbow CSV extension for blah 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 blah. I don't know. Whenever VS Code figures out some extension, it becomes over smart. Asks me to install an extension for it. No, I'm not interested. Let's leave it at that. It's very simple. If you're dealing with some CSV file like this, one of the ways you can read them is just by using your good old file read. But then I'll tell you another module about that. Talk about one more module. But now I can just type with open of inventory.csv as inv. I've got this inv to indicate inventory, and I'm just going to read each line from it. Each line has got values. Sometimes it's very likely that the first line can contain headers. So I'm going to skip the first line off and then start iterating over multiple lines. What I want to do is that I want to find out the net worth of my inventory. I want to find out what is the total price of all the products that I have with me. So if I want to do that, I need to process each line, and then I need to split them. After splitting them, I need to find out the quantity, price per piece, multiply them. So I'll get the total price for that one particular entry, one particular unit, not one unit, or one of the products which I have based on the quantity. And then I sum them up with the others, right? So how do I do all that? You can see the processing I'm doing here. It's pretty straightforward. For line in env, read each line. Then you need to split the line. These are all comma separated, so you can split based on comma. That works. And here when you split based on comma, because these are all containing just 3 columns, each of them has got 3 columns. So you can actually unpack them as product, quantity, and price is equal to. So try to print them now. I'm just going to print all these variables. You can just see what you get. I'll run this code. You can see it all works, right? The product, remember, the quotes are also included. How do you strip down this quotes, you may ask me? The double quotes, they look very messy. Within a single quote, there's double quoted string inside it. The double quotes is also included. You want to get them off? The way you can do that is, you can do this. You can actually try product is equal to product dot strip. Normally when you call strip, it'll strip the string off from white spaces surrounding them. Space, tab, new line, carriage return. If they are surrounded by those white spaces, it strips them. But strip, you can also pass what character you want to strip them off. So I can put quotes, the double quote. And you can see that the double quote is stripped out. You can see it's quite nicely fashioned. There's another problem. Quantity and price both are strings. Both of them are strings. And price also has a slash n at the end, because that comes at the end of the line, right? That so includes that. So we need to get all of these things done, which we need to convert this to integers. Let's see if we can convert them integers directly. We can do that right away here. We can say product, comma, right away here. I got all these 3 variables, but again, I want to transform them. So obviously quantity price is equal to product.strip of this. And we can just say maybe int of quantity. Quantity must be an integer, let's assume. Can't be a float. Can't say 3.4 items. 3 or 10 or 20, whatever that is. The last one is price. We can use it a float, but I will try using integer because I'm assuming it's all integral right now. So it's an int of price. You can see me using parallel assignment. You could also say product is equal to product.strip. Quantity is equal to int of quantity. So I'm replacing these three variables with those outcomes of these expressions, right? Which is going to transform all of them to integers and strip them. Looks like white spaces don't matter in a string, surrounding a string when you use int construct. You can see that. I did not have to call price.strip before I call int on it. The price was ending with a new line, but it's able to convert it to an integer without much of a problem. If the space is anywhere within a digit, then there's a problem. Otherwise, this will work. And now it's pretty straightforward. If at all you want to find out the net worth of this inventory, I'm going to copy this, and all those are for debugging. So I'm going to remove this line. I can just say, let's say net total is equal to 0. And you could use net total plus equal to accumulated to. We could just use quantity into price. And then print total price of the inventory equals, you could print net total. You can see all kinds of processing that we were able to solve with this, right? But here's the thing. Working with CSV could be a very common thing to do in Python. If at all you want to work with CSV files, rather than you splitting them and stripping them and doing all these things, is recommended, or I'll say rather suggested, to use a standard library's CSV module. But remember, if you want to do real analytics, then you should look at a third-party framework. There are a whole lot of them, but one of them that's quite popularly used is pandas. So pandas is a framework that makes things very, very easy and simple, right? When you're dealing with all kinds of tabular data. That's a tabular data, right? All kinds of tabular data. It can be an Excel spreadsheet, it can be a CSV, all that, right? I will cover that if time permits as a quick gist when I talk about modules in Python. Okay. For now, if you want to use a standard library module called CSV, you could actually use import CSV here. And then the CSV module provides a wrapper on a file object for reading or for writing. You open the file for reading, so that means you want to read in CSV file, use csv.reader. If you want to write to CSV, use csv.writer. And this wrapper, what it does is, it takes care of splitting or joining fields for every row. That split and join is taken care by the CSV reader and CSV writer. The much more sophisticated features that CSV has, where you can not just read CSV files, but also tab separated files, or maybe the files separated with colons, like etc password in Unix. There are ways to handle all of those types too, right? Extraneous tabular types. It's possible, as long as they're textual. But I'm going to focus on the comma separated versions, like in this inventory of CSV at this moment. So you can actually use import CSV, and usual with open off inventory.csv. I don't have to specify the mode as inv. Now what I need to do is I can just type maybe reader is equal to csv.reader of inventory. So I can assign it to a reader object. So this is a CSV reader instance. If you use csv.reader, this is suitable for CSV documents that may not have headers, or maybe the CSV headers don't matter to you. Even if they exist, it doesn't matter to you. Then use this simple reader object. So this reader object that is there, you can iterate over it by using this. You can say for directly row in reader, but try to print row. Just see what you get. You get a automatically tokenized list. Yeah, this does not convert the second and third columns to integers automatically. You have to do that. It tokenizes as a string. So it's a very simplistic parser, right? So this is mostly useful for scenarios where you want to, let's say, extract 2 columns from a CSV file, or you want to do some very basic manipulation and not analytics. If you want analytics, you don't need to write your own code. We need to convert them to integers and do the same logic which I showed you here. Implement this code. I want to leave it as an exercise for you. You can try it out. Right. This is how you read a CSV file. But if you have an inventory that has the header. Let me just try to show. Let me add a header to the inventory. Maybe I can just use something like say on top. I'm going to put it like this: product. So mostly if you create some Excel spreadsheets and save it as CSV, if you have a column headers, they could be saved as the first line header, right? I say product, quantity, and price, let's assume. The first row is a header row. Now the earlier code will not work. If you try running this code, this is going to fail. This code will fail because I added a new header there. You can see that. You know where it failed? First line had product, quantity, price as that words. You cannot convert them to integers. That's why it failed, right? You can see that. So one way to handle it is, you know that the CSV file has a header. You can skip the header. So for that, you can just do one read outside the for loop. You can say, yeah, you know, you can say inv dot read line. You can also get a little more smarter where you can get those headers, tokenize them, and create variables out of them, globals or locals. You can also use that. Any of these options can be done, right? So you can actually populate into your globals or locals dictionary or vast dictionary, and you can start creating variables. Not really Pythonic, don't do that. It will lead to unwanted runtime surprises. Okay, so you're determining variables based on the file contents can be very dangerous. Don't do that. I'm just telling you that flexibility is there, but mostly you just want to skip that line. Maybe if you know what the headers are, you can just create the variables based on that and make it work. Or maybe you can create a dictionary. You can also create a dictionary, and the dictionary will have keys, which will be the header names, and the values can be stored as appropriate things. Let us say I want to modify this time. I'll come to the next form, but this I'll show you. What I can also do is that I can improvise this code. Yeah. Okay. I can improvise this code. What I can do is this time I can create a dictionary. I'll just say maybe I'll call this inventory itself. Inventory equals create a new dictionary. Dot from keys. This is a use case of dot from keys. If you forgot what dot from keys do, go back to the session where I talked about dictionaries. One full lengthy session on dictionaries. Okay, go and look up that 1 hour video. But in summary, when you construct a dictionary and then say dot from keys and pass an iterable to it, what it does, it creates a key out of each item of the iterable. But this time, I don't just say read line. I should say read line dot split based on comma. Read line dot split based on comma will split the first line, product, quantity, and price. Creates keys from them. The problem here is that once you split it, each of those keys will also contain some extra double quotes. I want to get rid of that. How do I do that? Yeah, the code gets more complicated because a lot of nesting goes on. So I'll first prepare this whole thing. Okay, I'll just say headers equals. I can just use a list this time because I know the number of headers is not going to go too much, right? It's difficult to look at CSV files which are having about 1,000 columns. Yeah, 1,000 is manageable with a list. So I'm using a list here. So I can use the list using list comprehension, by the way. I can just use field dot strip the quotes out of them. Within single quotes, I have to put double quotes. The double quotes out of them. For field in inventory dot read line dot strip based on comma. Right now, I'll just print what this headers does. Let me get rid of all these things. I'm not really interested in reading inventory for now. So I'll just forget about net total. I'll print what headers is. Oops. Not what I expected. Not really what I expected. What really happened? Okay. inv.read line reads a line, no doubt. You know what the problem is? This one. Typo. I actually intended split, not strip. Strip will just remove the leading and trailing commas, which is pointless here. Yes, class. Yeah, mistakes do happen. So you learn from them. And yes, there's another problem here. The last one, the last price, right? It's got a new line. I thought I can do it in a single comprehension, but it doesn't seem so. Yeah, I can do this. Before I split, I strip. I do R strip to be more specific because I'm only worried about the trailing new line. R strip dot split. Okay, it's a one liner. You want this is debated whether this code is Pythonic. I have the habit of writing like code like this, but sometimes if you're worried about reusability, it's perfectly okay to write a headers is equal to empty list for field in inv.readline, right? And field dot r strip dot split. You can do all that things and append it to the list. That'll be a slightly sizable code with 3 or 4 lines in a for loop. But if you know how to use comprehensions and once you get very fluent in Python, this is what you'll end up doing because this looks more natural to you, right? So you want to store the field with the double quotes stripped out, both ends, right? I want this double quotes to be stripped out. This and this to be stripped out from every field. But in order to get each field, what I do, I need to split them based on comma. But before splitting based on comma, I need to get rid of the trailing new line because that will be added to the price otherwise, right? So that's why I'm doing a read line dot r strip, which will remove the trailing new line, trailing new line from that line, right? From the string. And once that trailing new line is removed, then you split based on comma and you get a list of fields. Each field, I want to get rid of those quotes surrounding them. I do field strip. And this what gives you header. So this is what I wanted. Now what I want to do is that I want to make this the keys of a dictionary. I want to make it a keys of a dictionary. And the way I do that is by using, I'll call this inventory is equal to create new dictionary dot from keys of headers. And I'm just going to print inventory this time. Yeah, this is what from keys does. The default being none looks very uncomfortable for me. I want to improvise it. So what I can do, let's see, that from key takes an argument. I think this takes a default. Yeah, no, value is there. That's right. You can just type from keys of, you could use the headers and the next argument is value. For the value, I can just use maybe, the default value is an empty list. Let's try that. This is what I wanted. I've created a dictionary, a skeletal dictionary, where the keys are based on the headers, right? And the values are empty list. Now what I want to do is, after which I will now start iterating over each line from the CSV document, for which I can say, I can use for line in env. I'm not using CSV module this time. I'm doing everything on my own. I'll show you. CSV makes it easy. What I'm doing here is done by CSV module. Come to that. Okay. So for line in env henceforth, what I can do is I can just type maybe product, comma, or I can simply use, p, comma, p, v. I could directly use dictionary of keys, but it actually makes the code more complicated to read. So I'm going to make it more elaborate. Okay. So you can make it a one-liner if you want to. I'm making it more verbose in this time. So it's a p, comma, q, comma, price is p again. So now I'll use product, no problem. Product, comma, quantity, comma, price is equal to, I can use inv dot split based on comma. Before I split, I'll also use r strip here. Get rid of the trailing new line, then split it based on comma, right? And then I can beautify the product and everything. We can do that while I'm assigning a dictionary now. What I'll do now is I can type inventory of product. Ah, this is a little tricky because how do you get the first item of a dictionary? I can't get the first item of a dictionary. Anyway, I'm hard coding things here. Not a good thing. Not a good sign. Okay. Oh, okay. I still have headers. I know this looks a little messy, but you can make it more multiple lines. I can say headers of zero. Headers of zero represents the first column. I'm trying to be super generic. I'm not hard coding the name of that column. The column name can change. Instead of product, I can call it something else. So I'm trying to make it very generic here. So I'll say, yeah, the variable called product quality price shows off. So then you can say column one, column two, column three if you want to. You don't really care, right? It's fine. So let's say inventory of headers of zero will represent the first key that is there, right? And dot append. See, it's a list. See, when you say dictionary of key, you'll get a value. The value here is a list. To that list, I want to append. What do I want to append? Product dot strip of quotes. And I can use inventory. This code is not very clean. This code is not very clean, to be honest. I could make it even better, but I'm going to leave it as an exercise for you to make it more cleaner. This looks redundant for me. See how we can reduce redundancy and how you can make the code more Pythonic, I would say. When I say Pythonic here, more readable, more succinct, right? This code is, I'm just typing it manually here. I'm looking at this. The moment I look at a code like this, it just comes to me like I can think from the back of my head that, I could make it better. A little more thought process. I can make it better, right? That is a kind of self-critique that you should have. So when you look at your own code, you should look at your code like a person who is reading somebody else's code, right? And then see, why is this guy repeating the same thing? There should be a way to optimize it. Yeah. I can't do it in a video, but I don't want to spill over more time. But I want to leave it as an exercise for you to try and see how you can make this code also more optimal. If you can come out with a more optimal solution to this, paste it on comments, what I'm showing you. I'm actually trying to populate the entire thing into a dictionary. That's what I'm trying to do here. So headers of one dot append. Again, that's a list. I want to append. This time I can use, int of quantity. Convert this to integer. Inventory dot of headers of two dot append of int of price. I'll give you some hint to make this code more succinct. Point one. If at all I read a field, and the field is only made up of numbers, I should be able to convert that to integer dynamically. I should be able to figure out whether that field is made up of numbers. I should be able to convert to integer dynamically and store it. And if the field starts, anyway, every field you can strip their quotes, right? The double quotes that is there. You can strip double quotes irrespective of whether they have it or not. It's super generic. Maybe you probably have a CSV file with multiple columns, and each one of them could be, some of them could be strings with double quotes surrounding them. Some of them are numbers. Some of them are strings again. So wherever you encounter strings, then all of them are strings initially. You anyway call strip on each of them. But after that, you should also check if they only represent numbers. Very likely you want to convert them to integer. You can convert to integer. You can do that. That's one solution. But that makes a lot of assumptions. Maybe you have a column that contains a telephone number. I don't want to convert to integer. That is a problem. So maybe you should also take some kind of a hint indicating, okay, about some kind of a structure or a template where I should be able to say that, the first column is a string, second column is an integer, third column is a float. So you should take that as a hint from some kind of a template list based on the types and apply those conversions dynamically. This is looking redundant for me. There are 3 columns is okay. What if there are 10 columns? This won't scale. That's what I mean, right? If you're writing code like this. These are ways you practice and try to make your code more better. And who knows, you might come at a better framework than the built-in CSV module. That's possible when you start refining your thought process and make things better. So I'll leave it at this. And ultimately what I'm going to do is that here, I'm going to print the inventory and you can see what you end up with. Something went wrong. What was it? Product comma quantity comma price is env dot r step dot split of comma. It says oh, I forgot to put oh, there's a inv here. That's bad. I should call line. I'm iterating over lines. Line is a string. Inv is a text IO wrapper. Yeah, typos do happen. You can see that product is a key. The value for that is, it shows motherboard 20. Oh, something went wrong. Did it? Did it? Yes, it did. Headers of 0 should give me a product. But why did it put everything in here? No. There's something went wrong here. Something went wrong here. So it looks like, here you can see that inventory is a dictionary. And we saw what the dictionary looks like. It had product, which was an empty list. Oh, okay. There's a reason for it. The same list that is there is commonly shared by all the three keys. Bad. The same list is actually shared by three keys. That was the reason. So the reason why this actually went wrong is that I created a list here. This acts like a value. There's one instance of a list. All the three keys are pointing to the same list, and that's why this problem happened. So I thought this could work. Sadly, it didn't. So yeah, this is an issue with mutables like a list. So you can just see what really happened was, three keys are there. Inventory, like you have three keys, right? Product, quantity. Let me just print it out. Product, quantity, price. They look like three lists here. But you know what? They all end up pointing to the same list. Let's verify that. How do I figure it out? When I look at the pattern of what happened, so I said headers of 0, that should be appended. Headers of 1 are appended. So you're appending to the same list, though you're looking from three different keys, right? So if you just try to print inventory, I'll just ID of inventory of product and ID of inventory of quantity. They both have the same IDs. So this is pointless. Right? This is pointless. So I thought I could use dictionary.from keys and shorten it. I need to create an empty dictionary and add the product and the each of these header elements must be added manually. Create a list the first time and append it to it. Okay. I think I will try to show you in the next session. I'll have to continue in the next session and show it to you about how this is done. It requires more amount of coding. But you know what? If you want to create this kind of structured data, you'll have all this kind of thought process where you need to make your code better. You'll have to add more features. You can see where I'm stumbling and where I'm failing, and you can see what's going on, right? It's pretty natural. CSV module, I want to show you, has a feature that tries to read every row into a dictionary, which makes it easy. I was coming to that, right? So I thought I'll create my own structure, but try and see how you can solve this. Hint, dictionary.setDefault might be required to solve this. Dictionary.setDefault. From keys is not going to help. In a loop, you might want to use dictionary.setDefault. Just giving a hint, try and see if you can solve it. I have the solution in the back of my head, but I could type it off and I'd explain it. So I'm going to leave it for the next session as such. Anyways, so right now I will wind up with telling you, end by talking about the CSV's dictionary reader in this case. So here, if you have the inventory here, which has got a key, it's got product, quantity, and price. And if at all, that means if you have CSV with this particular header, right? CSV with the header, you can actually use, rather than reader, you can use dictionary reader. Okay, so reader is equal to CSV dot dict reader of INV. Dictionary reader. Dict reader. So this returns a dictionary reader object. The only difference is that this automatically infers the first line as a header, uses them as the keys in the dictionary, and the value will be the column every time you iterate over it. So you can see what you get. So if you want to, let's say, read a CSV document into a records of dictionaries, each record is a dictionary, it is more convenient to do so, right? So this is what you should know. So I'm going to leave it as an exercise for you to see how you can improvise this code. So what I want to do is that what I really wanted was I want product and the value should contain only the product column, list of product column. And then I wanted, quantity should represent a list of quantity and price, list of price. That's what I wanted. Try and see if you can solve that. This didn't work, right? From keys didn't work. From keys will work if you're dealing with numbers or any immutable. So if you use a mutable, they'll all be shared because the mutable is constructed once and passed on to all these rows, right? We saw that. So that's why when you do append in three different keys, you're appending to the same list. That's why every member, see the product, it's got motherboard, price, quantity, RAM, price, quantity, CPU, price, quantity, everything. And if you look at this particular quantity also, it's sharing the same list. You can see. Price, same list. If you're able to fix it where I want to have product that only contains motherboard, RAM, CPU, PSU. Quantity contains only 20, 30, 10, 5, 7, whatever. And price contains only the last ones. That's what I want you to do. Okay. See how you can solve it using the dictionary methods. If you're able to solve it, do post in comments or mail them to me directly so I can have a look into it. And I will anyway show it to you how it is done in the next session, right? After this particular session as such. But for now, I just told you what are the things you can do with files. In summary, I talked about reading and writing to binary files and a common pattern for processing binary files chunk by chunk. That's a very common use case I found in practice. You're dealing with very large binary files. And then I told you how you can read first few lines of the file. One exercise I gave you is to try and find out how to read the last few lines of a large text file in a memory efficient manner. Just like I showed you how to implement head command. I want you to see how to implement the tail command. That's what I want you to try, right? And the other exercise that I want you to try out is try to fix this code. I'll leave as a comment here. Just say fix this code and see if you can come out with your own solution, right? At this, I will end this session here. I think I talked about file IO. In the next session, after showing you the solution of this, of course, I'll focus more on modules in Python, standard library modules that you should know about. I will start off because I started with file IO. I'll talk about some things surrounding it, like how do you manage directories and paths and so on. I'll talk about that, give you some insight about os.path and pathlib module, and all these surrounding features and functionality, some legacy code, some legacy modules, and the modern equivalents of them. I'll give you some insight about it in the next session. And following which I'll cover a few more sessions where I'll talk about other modules that is worth knowing in Python. What you can do with sys module, os module, time module, shell, pickle, couple of these common modules that you would normally end up using. If time permits, I'll also talk about collections module and also func tools, iter tools. I'll give you some insight about those modules. I think I spent a couple of sessions for that. Hopefully after that, I will talk about Python code maintenance. How do you maintain your Python code? And that should wind up this overall series of this particular tutorials I am doing. After which, based on the feedback and based on your inputs, I will try doing more tutorials on advanced features, mostly about multi-threading and multiprocessing, mostly concurrency and parallelism, that is, and also maybe on object-oriented programming and design patterns. So I can also make videos on that. It all depends on how many views I get and overall feedback from the subscribers. That's what determines whether people really find this video more enjoyable. If you like this video, if you like what I'm doing, and if you want me to continue doing videos like this in this kind of a series, do hit the like button. And if you're not already subscribed, please do subscribe. And do post in comments if you have any queries or doubts. And yeah, if you really like what I'm doing, yes, also can also post it on comments. And I will see you in the next one. Thank you very much.